Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Hadirah binti Aziz. My matric number is 1190969. In this video, I would like to share to you all about conditional probability and independence in SOA problem solving. The source of the equation that I choose is from a text study manual for exam P 2015, problem set 2, question number 3, page 75. Okay, now let's see the question. What is the question? The question said is an actuary studying the insurance preferences of automobile owners made the following conclusion. First, an automobile owner is twice as likely to purchase a collision coverage as disability coverage. Second, the event that an automobile owner purchases collision coverage is independent of the event that he or she purchases disability coverage. For the last one is the ability that an automobile owner purchases both collision and disability coverage is 0.15. Based on the question given, I identified there are two events occur. The first event is an automobile owner purchases collision coverage, which is representing as C, and an automobile owner purchases disability coverage, which is representing as D. From the question, I also can get information. Okay, for the first information I get is probability of C is equal to 2 probability of D. As we can see, the sentence mentioned about twice as likely to purchase collision coverage as disability coverage. Okay, for the second information, I identify purchases collision coverage is independent. Okay, so the independent is the event that purchases disability coverage. As we already learned that the independent event is referring to probability of C intersection with D equal to probability of C times or multiplies with probability of D. Okay, for the last information I get is the probability that purchases both collision and disability coverage is 0.15, which means the equation is probability of C intersection with D equal to 0.15. Now let's look what the question wants. We are asked to calculate the probability that an automobile owner purchases neither collision nor disability coverage. Therefore, the problem we need to solve is probability of C prime intersection with D prime. So, in this video, I will explain to you all how to solve the question. Let's go! Now, we can visualize in Venn diagram. For easier to understand, the blue one is for probability of C and the pink is for probability of D, and the intersection between of these two colors is 0.15 as probability of C intersection with D. And we are asked to find here the probability that somebody gets neither collision nor disability coverage. To get probability of C prime intersection with D prime, I use the De Morgan law, which is probability of C prime intersection with D prime equal to 1 minus probability of C union with D. The De Morgan law tell us that the probability of event A complement intersection event B complement plus probability A union D is equal to 1. But the main problem is we don't have enough information to actually solve probability of C union with D. So how to obtain it? By using the following manner: probability of C plus probability of D minus probability of C intersection with D to get probability of C union with D. From this formula, we only know probability of C intersection with D, which is 0.15. So now let's find probability of C and probability of D. For the calculation, we are given the events are independent. So that means the probability of C intersection with D is equal to the probability of C times with probability of D is 0.15. I am using the second and third from the information given. For the first information say, the probability of C happening equal to 2 times the probability of D. So the equation is 2 probability of D multiplied with probability of D equal to 0.15. Now, I multiply this 2 times the probability of D square root is equal to 0.15. So, I can solve probability of D by dividing 0.15 with 2 and get 0.075. And taking the square root to the right side, we can determine the probability of D is equal to 0.27386. From this, we also can get the probability of C, which is probability of C is equal to 2 probability of D. So, probability of C is 2 times with 0.27386. And the probability of C we get is 0.54772. So now let's look for the Venn diagram again. We are near to complete the Venn diagram as the value for probability of C is 0.54772 and the probability of D is 0.27386. From the value of probability of C and probability of D, we also can find or can solve the probability of C prime intersection with D prime. So let's go to find it. Finally, we can figure out probability of C union with D equal to probability of C plus with probability of D minus with probability of C intersection with D, which is 0.54772 for probability of C plus with 0.27386 for probability of D minus with 0.15. So finally, I can get the probability of C union with D is 0.67158. We almost done since we know the probability of C and probability of D are complements to each other, so that we can figure that the probability of C complement intersection D complement is equal to 1 minus the probability of C union with D, because I follow the Morgan laws. So the equation is 1 minus 0.67158. And I can solve the final answer is 0.328419. So finally, we already answered the equation, which is the probability that an automobile owner purchases neither collision nor disability coverage is 0.328419. As a conclusion, to solve this question, we have to know two concepts and theory of probability, which is the independent theory and the De Morgan law. I hope this video will help you to find the answer. That's all from me. Thank you. Bye.